Hello, everybody, and welcome to another episode of Mental Architecture Building the Mind One Moment at a Time, based off of my book by the same name, available exclusively on Amazon for purchase. Today's episode is called Problems with Logic, and it picks up where the last episode left off with the inherent limitations with mathematical systems. We're going to be a little more broad today and talk about how logical systems are inherently flawed and make assumptions that we have to rely on in order to use them. As we try to uncover the truth about our world and the way things work, we rely on formal logical systems to analyze and interpret these things. And a famous logician, Austrian-Hungarian logician by the name of Kurt Gödel, came along in the early 20th century and came up with Gödel's incompleteness theorems. I'd like to share those with you. Number one, any consistent formal axiomatic system F within which a certain amount of elementary arithmetic can be carried out is incomplete, i.e. there are statements of the language of F which can neither be proved nor disproved in F. Number two, for any consistent system F within which a certain amount of elementary arithmetic can be carried out, the consistency of F cannot be proved in F itself. So within any formal system, whether that's mathematics or another logical system, what the first part of Gödel's incompleteness theorem says is that there are going to be statements and problems for which that formal system can neither prove nor disprove that statement or problem. So there are going to be things that just simply cannot be proven about that system. And the second incompleteness theorem basically says that any consistent system containing some kind of operations, arithmetic operations, you can't prove the truth of that system itself using the operations within it. So there are basically going to be logical contradictions in any system, and there is no universal system that can prove everything. There's no universal mathematics language that is airtight and contradiction proof. All logical systems have limitations to them. They all have inherent contradictions built into them, and the only way to deal with that is to extend your logical system or develop another one alongside it. But even that one that you develop is going to have problems with it, and so on. So this creates a real issue and dilemma with logic in general. Now, you don't need sophisticated mathematics or logic to understand Gödel's incompleteness theorems. We can look at a really simple example. You. So every day you get up, you look at yourself, and you can recognize who you are. But if you had to develop a system to describe you, it would be very limited in what it could do. You could develop a system to describe your skin tones, describe your clothing, describe your personality. Yet all of those descriptions that you would come up with would never be you. They would just be a description of you. And it doesn't matter how deep down you drill and how sophisticated you get, how detailed you get. You can extend the system all you want, but that system will always be a system. It will always describe you, but it will never be you. And that's the issue with mathematics. Mathematics describes the world around us as best as it can. It describes the rules that we observe as best as it can. And it also describes things that we have yet to discover or that may not even exist. But mathematics will never be a perfect language. It will never describe everything in existence. There is no way to have a theory of everything, because it would just be a theory. It would not describe the actual reality. That reality is somewhat intangible to the rules of logic in a weird kind of way. So you can never truly know yourself. You can look in the mirror and everything that you've labeled yourself as is just a label. Everything you think about yourself is just a thought based on the rules of grammar and English language. Your height is a measurement based on the laws of mathematics. In a way, this makes you an illusion to yourself, and you can never truly know what you are. With that being said, and that is a strange and earth-shattering thought, I'd like to take you to a quote from Richard Hamming that explains the problems with logic a little bit further. Just as there are odors that dogs can smell and we cannot, as well as sounds that dogs can hear and we cannot, so too there are wavelengths of light we cannot see and flavors we cannot taste. Why then, given our brains are wired the way they are, Does the remark, "Perhaps there are thoughts we cannot think," surprise you? Evolution so far may possibly have blocked us from being able to think in some directions. There could be unthinkable thoughts. This quote absolutely blew my mind when I first read it, because it definitely resonates as something true. There are so many things that we can't see, hear, taste, or touch because our brains just aren't wired that way. But it doesn't mean that those things don't exist. It just means that we have a very severely imperfect understanding of our world, including ourselves and including everything around us. And you don't have to look far for this imperfect understanding. Our brains lie to us all the time and bring order to things that don't really have any order or have the kind of order that we think they do. So let's take a real simple example. And this is something that I kind of thought of when I know I teach math, that's my main career. And when I'm teaching about just the most basic of things in math, like points and lines, circles and rectangles, you have to stop and think for a second, do these things actually exist in the way that we think they do? So I want to put a picture up of a point and then talk a little bit about it. So this is a point, not the most exciting thing in the world, but what is it really? Your brain looks at it and says, that's a point. But if you were to zoom in on it, it wouldn't really look like a point anymore. It would start to look a lot more like a collection of pixels. And it's not even perfectly circular the way that a point would be. In fact, any point you make, whether it's with a pen or pencil or even on the computer, is never going to be that perfect circular little point. Plus, what is a point anyway? A point's supposed to be this zero-dimensional object you can't even see. If you're looking at it, it's not a point, but we have to think of things like a point. Same thing with like a straight line. If you look at a straight line, no lines that are supposedly straight are ever straight. There's little ridges and grooves and edges, because aren't lines made up of collections of infinitely many points, or just a whole bunch of points strung together in this continuum? Everything, every geometric object that we think we know, we really don't know when it comes down to it. It's like mathematics is this big elaborate lie. Not in a bad way though. Maybe we're using the word lie isn't the right word to use, but I just think that what we take for granted is, for instance, geometry is really a collection of made-up ideas, imaginary things, and we just do our best to apply these tools to the world around us, but nothing in nature is a perfect circle. Nothing is a perfect rectangle. There are no straight lines. You look at them closely enough, you will find that they don't really look like that. So if you can come to accept that mathematics and other logical systems are just approximations to the reality around you, it really makes you start to question reality. It makes you start to question just what you see around you as, is it real, or is it what I am making it out to be, what my brain is interpreting it as? But what is actually there? That might be something that we can never know. Maybe we're not meant to know it. But it still is quite an interesting paradox, because if we don't rely on these logical rules and systems, then we'll just go through this world entirely aimlessly. Every animal and all humans need some kind of logical system to reason with, even if it's just simple instinct, or else we won't be able to survive. So I'd like to take this one step further. In my next video, we're going to go and talk about object recognition again. We talked about that back in chapter 1, but we're going to look at it from a new perspective, no pun intended. So thank you very much for joining me today for Mental Architecture, Building the Mind One Moment at a Time. And I hope that you will continue to join me with my video next week and for future videos. Please be sure to like, comment, and subscribe below. And I look forward to seeing you guys again next time. Take care.